In this example, we're going to quickly exercise the notion of coterminal angles. Let's read the problem. Find all angles that are coterminal to pi over 4. Next problem, find all angles between negative 2 pi and pi that are coterminal to pi over 4. So just a reminder, so two angles, so angles are coterminal, so coterminal angles was the angles are different, their difference is integer multiple of 2 pi. Okay, so an even multiple of pi. Once again, the terminology for coterminal angles was such because two angles were coterminal if and only if their corresponding geometric angles coincided. Okay, so let's find all angles that are coterminal to pi over 4. That really is a piece of cake problem by the theory that we just studied. All angles coterminal with pi over 4 are all angles of the form pi over 4 plus 2k pi. Here k is an integer. So this k is an integer, so 2 times k is an even number. So if I write 2 times, so every even number can be written as 2 times an integer. So this gives me this. So this gives me the set of all angles which differ from pi over 4 by an even multiple of pi. Now, the real problem here is the second part of the problem. So here's what we're really being asked to do. Among all of these numbers, we're asked to find those that happen to be in the interval between negative 2 pi to pi. So how do we do that? Here's a procedure which is fail-safe for an exam. So what I'm trying to teach you right now is not some algorithm how to write a program to do that, or I'm not trying to teach you a recipe that could be that is a part of a mathematical proof. I'm trying to give you a practical skill for listing the numbers among those infinitely many numbers, the finitely many that happen to be in this interval. So I'm trying to give you a practical procedure for listing them in an exam setting. So here's what you do. You write the numbers in an infinite list. So in the middle, you write the number pi over 4. And then you write pi over 4 minus 2 pi. So here we're having the number k equal to 0. Here we're having the number k equal to 1. And so 2k is negative 2. Here we're having 2k equal to negative 4. So this corresponds to k equal to negative 2. Here we're having k equal to 1, which corresponds to, well, if k is equal to 1, then 2 times 1 is 2k. And here we're having k equal to 2. So what you do is the following. You take your starting angle, and then you copy that angle multiple times, and then you start subtracting even multiples of pi and adding even multiples of pi. How many should you write? The rule is the following: write as many terms of this infinite sequence to the right, so that you pass the number pi. So ensure that the last number you wrote, so the rightmost number, so ensure that this rightmost number, so ensure that the last number is greater than pi, is greater than this number. Okay, so if you want to find all angles in that particular interval, you start listing all coterminal angles until the angles you have listed surpass the number pi. You can also go beyond that. So if you don't want to think very, very hard of, well, how does exactly pi compare to pi over 4 plus 2 pi or pi over 4 plus 4 pi, you can just write many, many terms until you're absolutely sure without any computation that the number you have written here is bigger than the number that you see there. Same story to the left. So to the left, you make sure that leftmost number is smaller than the left-hand point of the interval in which you want to fit all of your coterminal angles. Now, once again, it is okay to go. It is okay to write extra terms to the left. You need to go to the left of negative 2 pi, but you can go even further to the left. So if you're not sure how pi over 4 minus negative 4 pi compares with negative 2 pi, just subtract another 2 pi. So write as many terms as your heart desires. Okay, so now that you have done that, what you do next is you compute these numbers. So you compute actual values here. You can add them as fractions, or if you can, maybe not, you don't need to write, you can compute them in your head, and you compare your computations with the numbers pi and negative 2 pi. And what you do is you cross out those terms that do not lie in the interval that was indicated in the problem. So this particular problem asks us to find all angles between negative 2 pi and pi. So pi over 4 plus 2 pi, that's clearly bigger than, so this number is clearly bigger than 2 pi, because it's just, and that's clearly bigger than pi. So that number is outside of this interval. This number is even larger, so we have to cross it out. And by the same token, all numbers in these infinite dots, they have to be crossed out. Now pi over 4, that is less than pi, and it's actually a positive number, so it's bigger than negative 2 pi. So that one, we shouldn't cross it. This number here, we shouldn't cross it either, because it is negative 2 pi plus something positive. So it's automatically greater than negative 2 pi. And it still is negative because pi over 4 is much smaller than 2 pi. So that's still less than pi. So that number here is between negative 2 pi and pi. And finally, this number here, that is less than negative 2 pi. So this is less than negative 2 pi. Why? Well, because pi over 4 minus 4 pi is certainly equal to, let's see, well, I guess it's negative 3 pi minus 3/4 of pi, which is definitely less than negative 2 pi, right? Because you add pi to this, and this is less than that, and you can just forget about that term. So we need to cross that term, and by the same token, all terms to the left of the first term on the left we crossed, they also get crossed out. And that's our final answer. These are the two angles, coterminal with a starting number pi over 4. So these are the two angles that lie in the interval between negative 2 pi and pi. So our final answer is pi over 4, and pi over 4 minus 2 pi, that happens to, if you compute it, you will see that you can compute that to negative 7 pi over 4. Now, I want to point out something. At first glance, this procedure looks deceptively easy. However, this procedure will arise as one step of solving a much more complicated trigonometric equation problem. So later on, we will study tricky trigonometric equations. And so we're going to have to do a lot of steps to solve these problems, but at some point, we will boil down that difficult trigonometric problem to the problem of finding all angles coterminal with a given angle within a certain interval. And when that happens, sometime in the future, this procedure will be coming very, very handy. Something more. This procedure, it looks deceptively easy, but in the context of that future problem type that you're going to see later, so in the context of that future problem type, this technique is not going to be so easy. And if you have not exercised yourself on this technique, you may find some aspects of trigonometric problems to be quite difficult. So please try to exercise this procedure, and I highly recommend using this method of writing, of listing numbers and crossing them out as a practical tool for doing things efficiently in an exam setting.